Okay, so we've already seen that the linear reasoning with the rules of inference that we've defined so far is not sufficient to to prove that everything entailed by a set of premises in propositional logic. So we need more powerful logic, or at least we need to add to our logic. The Mendelssohn system, it's a well-known system for propositional logic, and it can prove all logical consequences from a set of premises expressed using only negation and implication operators. Unfortunately, the proofs are really complicated. I don't know them, so I can't even tell you, but I'll take the word of the book. The good news is we can eliminate much of the complexity. We're going to try to do that by using structured proofs. So this video is an introduction to structured proofs. Okay. Hypothetical reasoning relies on structured proofs. So you probably are asking, what is a structured proof? That's the first thing we'll talk about. It's like a linear proof in that there are sequences of reasoning steps, just like we did before. Structured proofs allow us to group sentences into subproofs and superproofs. That's new. We haven't done that before. So that's the structure in the structured proof. So let's see what it looks like. Here I have written a structured proof out as an example. So let's take a look at how we write the structured proof. This is what I'm going to call the main proof. Now notice that I have one long continuous line here. That represents the main proof. This is what I call the subproof. Notice how there's a shorter line that doesn't completely encompass the entire proof. That's called a subproof. Okay, just want to get the terminology down. By the way, going back, sometimes the main proof is called a superproof because you can have multiple nesting levels, and so the proof level above the subproof might not be the main proof. It might be just a higher level of proof called the superproof. Okay, moving on. I don't want to belabor the point too much. So we got some rules for subproofs, and these rules, there's no way for students to learn them by you telling them they have to practice proofs to get these rules down. And you're going to have to provide them with numerous opportunities to practice. First rule is that you always open a subproof with an assumption. Second rule, you can assume any logic sentence for your assumption. Now, okay, so students would be saying, oh, well, why don't I just assume the thing I'm trying to prove, and then I'm done? But the third rule is no conclusions or assumptions within the subproof can be used in the main proof or the superproof. I'll get to that more clarity in a moment. And the reason for number 3 is because all the conclusions in the subproof are based on an assumption which may or may not be true. In this case, I have assumed P. We don't know if P is true. In fact, P can be true or false. In fact, these two premises do not entail P, which means we cannot know whether P is true or false based on those premises. Fifth rule, you apply the rules of inference to the assumption in the subproof, apply the rules of inference to the assumption and any subsequent inferences in the subproof. So I can apply rules of inference to this assumption, here I did, and even rules of inference to the conclusion within the subproof. Okay. Number 6, you may use any premises or inferences derived in the main proof up until the subproof. So notice here, I'm using 3 and 1, that is, I'm using the assumption and the premise from the main proof. Here I'm using 4 and 2. I'm using one of the conclusions from the subproof and one of the premises from the main proof. So when you are applying rules of inference in a subproof, you can use anything that came before it in the subproof or the main proof. Okay, moving forward. Always close your subproof and return to the superproof using implication introduction. So notice how I've completed my subproof here, and the way I return to the superproof, in this case the main proof, is through an implication. The antecedent of the introduced implication is always the thing that you assumed, and the consequent is always the last thing that you concluded in your subproof. Okay, let me say that again. When you're finishing a subproof, you finish it always with an implication. The antecedent is this right here, and the consequent is this right here. In my case, P implies R. And the consequent of the introduced implication must be the final logical sentence in the subproof. That's how subproofs conclude. So the purpose of a subproof then is to introduce an implication to the superproof. That's what subproofs do. Let me kind of graphically state it. In the subproof, you will be making an assumption, applying some rules of inference, and drawing some conclusion within the subproof. Again, assumption. Here it is. Rules of inference. In this case, I applied 2. Conclusion. Here's the conclusion in the subproof. There it is. And this means that if I assume phi and then use phi to prove psi, then I have proven that phi implies psi. I have not proven phi. So I cannot conclude phi. Notice that out here, I cannot conclude P. I can conclude, however, if P is true, then R is true. And that is not the same thing as concluding that P is true, or that R is true. Okay, this is a really difficult concept for students to get, and I think there's no way for them to get it based on you telling them this overview that I've showed you. In fact, if you've never experienced this before, I'm pretty certain you're not going to get it either. So what you have to do, and one of the reasons that I have this video for you, is you're going to go and do some practice, and then you're going to come back and listen to it again, possibly, and say, oh, now it makes sense. Nothing makes sense this complex unless you have some experience doing it. Okay, so let's give an example of a structure, or let me restate what I've already stated. The purpose of a subproof is to introduce an implication to the superproof. That's the purpose. Remember, we make an assumption, we apply some rules of inference, we draw a conclusion, and then we exit by saying phi implies psi, where phi was whatever assumption I made and psi was whatever conclusion I made within the subproof. Up here, here's the example. That's phi, my assumption. Here's my conclusion. That's the consequent of my implication. And that's how you build it. This is a new type of rule of inference. It's the kind of rule of inference that we will use in structured proofs. And I'm going to write it this way. And this says, if psi is provable from phi, then we conclude phi implies psi. Let me say that again. If psi is provable from phi, then we conclude phi implies psi. This is called implication introduction. Now, this is a structured proof, and remember the word structured proof, what that means is there's a subproof structure built in. We define a structured proof of a conclusion from a set of premises to be a sequence of possibly nested sentences terminating in an occurrence of the conclusion at the top level of the proof. Oh, that just sounds so hard to understand, but we'll go through it. Here's what I'm saying. The difference in these structured proofs is the subproofs, but the linear fashion that we apply logical rules of inference doesn't change. Each step of the proof must either be a premise at the top level or an assumption other than the top level, or the result of applying ordinary or structured rule of inference to earlier items in the sequence. What I'm saying there is what I said before, that you can use any premise or earlier conclusion in your subproof. Okay, that's enough for now. We're going to go into the Fitch rules of inference, the rules of inference that we will use in these structured proofs.